Hi everyone, I'm back with another interesting Colab notebook for machine learning. Today we will see decision tree machine learning project, simple project, basic. So first of all we have mounted our drive. Then next step, same as before, importing the libraries. The major libraries used are Seaborn. We have imported Seaborn as SNS. Seaborn is used for graphs, types of plots, heat maps, and others. Sklearn for our models and all other things, accuracy, performance metrics. Then pandas is PD, matplotlib pyplot as PLT for plotting. After that, we read a CSV data file that is stored in my drive. So I have read CSV, converted it into data frame using pandas.read CSV function, stored it in D. So this is my data. We have these columns: pregnancy, glucose, blood pressure, skin disease, insulin, BMI, diabetes pedigree function, age, and outcome. Outcome is whether he has diabetes or not. That is the result 0 and 1. So these are the factors on which diabetes is depending. This is the outcome. Now, first step, as always, is data analysis. So for analysis, we can use d.describe for mathematical analysis. One thing we see in this data set is that everything is already numerical. There is no categorical data, so we do not have to convert any category to numbers. And the next we see by plotting something of plots and analysis. This time we will do. So for this we have set the figure size. Figure size is the figure size. This figure size which you see is fixed size in plt.figure. Now we have plotted a bar chart. So plt.bar, d dot columns are the column names on the x-axis, and d dot describe dot row of max. This was d dot describe, and we have taken the max. So these values are being plotted in the bar chart. So we see insulin has the highest maximum value, and these have less values. So this was just a chart to analyze our data. This is how you can do it. You have different types of plots and charts. We can use those. Another is d dot correlation. Correlation gives every column's correlation to every other column, and we have mapped it in heat map. We have taken heat map from SNS, that is seaborn.heatmap d.correlation. A naught is equal to true means we are writing those numbers in each cell. If we do not write this, these numbers will not be displayed, and we will have to see from this. So what shall we see through this heat map and correlation? We see 1 in this diagonal. What does this 1 mean? 1 means is pregnancy. 1 is for pregnancy. That means 1 is correlated. Pregnancy is 100% correlated to pregnancy. And this is obviously true, that pregnancy is 100% correlated to pregnancy. We shall get correlation 1. Glucose is 100% correlated to glucose. Now the major thing that we have to see in this is this one, this column, outcome, and these attributes. So what we see in this is outcome is 47% dependent on glucose. Glucose has 47% correlation. This is the major thing. Means glucose is the major factor deciding our diabetes. Others are BMI, age. Age is also an important factor than pregnancies. And less dependent factors attributes are blood pressure and skin thickness. This is what we see through correlation. Zero correlation means there is no correlation. Positive means it is directly dependent, and negative means it is indirectly dependent. So this was what information we get through the correlation matrix. This is what is used for analyzing our data, which attributes are important, which are less important. So this is some graphical analysis. After this, we see how many columns, how many values, and what is their type. So for that we have used d.info method. So we see there are 768 not null values, means there is no null value in them. So this is good for us. We do not have to do any data pre-processing. Data is already in right shape, already in numbers. We can directly go for our model training and splitting. So the next step comes same. We have to get x and y, the attributes and our target. So we have left the last column and taken all others in x and the last column in y. We have printed those. After that, the next step comes is splitting our data for training data and testing data. For that same process we will do sklearn.model selection. We will import train test split. Train test split is the function used to split our data. We provide the x and y and the test size we can give. We want 20% testing and 80% training. So we have given the test size is equal to 0.2, and after that we will get four things: x train, x test, y train, y test. We have printed those. The next step is importing our decision tree model and fitting it on our training data. So we have imported it from sklearn.tree. We have imported decision tree classifier. Now decision tree algorithm has two types, two processes it uses to make the tree. First is information gain or ID3. Second is GINI index. Information gain, the more information some attribute gives, the first node is made from that. And GINI index is the lesser the impurity that will be selected as our root. So these are two criterions, but we do not have to go into the theory. If in programming directly, all functions are there. So we have used GINI index. Second, other is ID3 algorithm. We can also use that, but we have used GINI index in this. So after getting the decision tree, we are fitting it on our training data. We have fitted our model. Now after that, we see this is our y test. Now we have to get y predicted on the testing data. We will use our model. It will predict cl.predict on x test. For this test, what shall be the prediction? We'll store it in ypred. So y predicted is this. This was actual outcomes for those things, and this is the predicted outcome. Now using these two, we can get all our performance evaluation matrices. Last part of the code is performance evaluation. So we take the accuracy score from sklearn.matrix.accuracy score, ytest and ypid. So we find that our model is 70% accurate. We get 70% accuracy. Now after that, we can also print the confusion matrix that will give true positives, false positives. So this is our confusion matrix. To better visualize it, we can again use heat map. So these are true positives, true negatives, true positive, and these are true negative. These are false positives, false negatives, and false positives. Now the classification report is the last step. So our accuracy score is 70%, and precision recall others we can find through this. So this was all about the basic decision tree model, predicting diabetes or not, simple data set, easy processes, and some graphs, basic introduction to graphs. This is how the machine learning works. I hope you guys would have got a gist or idea of how you can train your own models on the datasets and do all kinds of predictions and use it for your prediction and applications. So this was all for today's machine learning project. I hope you guys would have loved it. Thank you. Have a nice day. Subscribe the channel if you liked this video.